we're back. It's time to talk about chapter 6, and in this chapter, we're going to talk about how memories are acquired, and we're going to talk about that part of the memory system that focuses on whatever you're currently thinking about. So, let's go ahead and get started. All right, our list of topics is kind of long and kind of varied. So first we'll do a big overview of the acquisition, storage, and retrieval systems in memory. Then we'll talk about the route into memory, which is how we acquire information. We're going to take a closer look at what our textbook is referring to as working memory, and very commonly, even in introductory psychology textbooks, they call working memory, but I'm sorry, that grates on me, and I'm going to call it short-term memory. Then we're going to talk about how information gets into long-term storage. And then we're going to talk about factors like meaningfulness and making connections to existing memories. And then we'll talk about the usefulness of organizing information in our attempts to memorize information and the role of mnemonic techniques. And then finally, we will talk about some of the research that has focused on memory acquisition. All right, so it's a pretty long list. It's a pretty detailed chapter, so let's get going. All right, let's talk about immediate memory. And I just told you the phrasing is starting to grate on me about how people are talking about it lately, so let's clarify. Immediate memory is also known as short-term memory. It's things that you have just, literally just processed. Probably within the past 30 seconds. It's not talking about things that you learned yesterday or last week. Sometimes we call this working memory because it's what you're working on right now. It's what you are currently aware of right now. It really depends on the researcher, the memory model, what term you're going to see. I guess what's been grating on me is that they've been talking about one model that uses the phrase short-term memory and substituting the word working memory, the term working memory. And that bothers me because that's not how the model talked about it, but I guess more recent researchers have adjusted the existing model. I guess they feel like that's an okay thing to do. Bias alert. I call it short-term memory. If I mean working memory, I will talk about something different because working memory is, in fact, something different from short-term memory. Now, hopefully, by the time I get done talking, you'll at least understand why I keep them separate, and maybe you'll join me. Maybe you'll feel like it's worth distinguishing between short-term memory and working memory. All right, enough defensiveness, enough explaining things. Let's get into the modal model, which is the model that offered the phrase short-term memory. So what is this model? It was offered in 1968. This model was based on observations of how computers of the time worked. And they said, maybe this is how human memory works also. So you have to forget what your actual computer works like now. Anybody who's maybe over 40 might have a concept of what computers used to work like. But anybody who's less than 20, you're not going to understand the relationship between this model and then how computers work at all because computers don't work like this anymore. They fixed a lot of the problems. So first off, for human memory, we have the information coming in from our five senses, which we've talked about in previous chapters, right? So you have these five senses that can each hold very briefly exact copies of what's out in the world. So on your actual retina, you will retain a very brief exact image of what's out in your visual field. In your ear, you'll hold it in your ear a little longer, but you'll hold a brief exact replica of what just came into your ear. These are what we call sensory memories because these are memories that are actually being held in the sense organ itself. If you pay attention to part of that information, that will lead the information to transfer into short-term memory. So all the things that are out in the world that are affecting your retina or affecting your cochlea in your ear or that you're smelling or tasting or that has touched you. There's a lot of information out there. Only the part that you pay attention to will get shifted into short-term memory where now you can focus on it and maybe process it more deeply or thoroughly. Short-term memory is where we rehearse information. Again, this is an experience that a lot of younger people probably have never had. But in the olden days, before we all had caller ID and things like that, we oftentimes had to look up our friend's phone number. And if we didn't have a phone book with us, we would call this old-fashioned thing called 411, often called information. And you would say, I'd like the number for, and you could ask for a business or you could ask for a private person. If it was, a child, you'd have to know their father's name in order to ask, stuff like that, because that's how it was listed in the phone book. So it was very antiquated. This is a story from maybe 30 years ago. A lot of times, if you didn't have a piece of paper to write the phone number down, you would have to hold it in your short-term memory until you could dial it. So 411 would tell you the number, and luckily back then, they would tell you just a seven-digit number. They wouldn't tell you a 10-digit with a area code. It was strictly just the seven digits. So the operator would literally read the number out to you. A little bit later, maybe 25 years ago, the operator would like connect you to a system that would read it to you, but it was being read aloud to you. And you had to hold it in short-term memory through rehearsal. So you'd say those numbers over and over and over again inside your head until you could get them dialed. That's an example of maintenance rehearsal. There's different kinds of rehearsal that you can engage in, but what we're talking about is things that you do to keep that information active in your short-term memory store, to keep it there so that you can continue to pay attention to it. Information that's processed well enough, and there's a lot of different ways to process it well, and we'll talk about that as the chapter goes on. Information that's processed well enough will get transferred into long-term memory. I have a little key down here at the bottom for you. Hold on, I thought it was going to pop up earlier. STM, short-term memory, LTM is long-term memory. So if you process it well enough, it'll transfer to long-term memory. Now there's a reverse arrow going from long-term memory to short-term memory, because anytime you want to think about something that you have stored in your long-term memory, you have to pull it back into short-term memory in order to think about it. So anytime you want to reflect on your first day of school when you were in kindergarten, you have to pull it out of long-term memory and place it into short-term memory where now you can pay attention to it. It's from short-term memory that you're going to be able to produce some kind of response output. So if I were to say to you, tell me about your first day of school ever, you would pull the information out of long-term memory, reflect on it in short-term memory, and produce your response based on that information that's currently being held in short-term memory. This is going to be important when we get into other chapters and we talk about memory errors and things like that, because what if you don't pull out all the details from long-term memory into short-term memory? What if you pull details that aren't related to the actual memory into short-term memory, and then it becomes, as far as you're aware, part of the memory, right? This is a great opportunity for error in our memories. So this is the basic model, and it's called a modal model because the theorists thought that the information moves from one mode to another mode to another mode. So it's a sensory memory initially, and then it becomes a short-term memory, and then it becomes a long-term memory. And so these different modes of memory happen here. Some people call it the box model of memory because they say it moves from the sensory memory box into the short-term memory box, into the long-term memory box. So some people call this the box model. Now, the way that this is analogous to old-fashioned computers is you could think about the sensory memory being like you typing on a keyboard in sort of more modern computers. Older computers, maybe it was putting one of those IBM punch cards into it that contained the coding that was necessary to get the computer doing what it was going to do. Even older computers, there were actual switches that you had to physically switch in order to make the processes happen. Sensory memory for a computer would be one of those kinds of inputs, right? Short-term memory for a computer would be whatever's displayed on the screen at the time. Short-term memory. Now, this is a good comparison. When I was a college student, I was very excited. I was actually in grad school when I got my first my own computer that kind of you might recognize as a computer as a younger person. It was a Commodore Colt. very exciting. And if you were working on a paper in your Commodore Colt and you turned off the hard drive part, the big base of the computer, if you turned that part off without having saved your paper, the paper would be gone. No memory in the computer at all. That's not how computers work today, is it? If your computer's power were to get interrupted, the next time the power came back and you launched that word processing software, for example, your computer would say, I found unsaved material. Do you want to retrieve it? Right? Do you want to, what do they call it? Not retrieve it. Oh gosh, you guys are probably yelling it at the screen right now, the term that they use. But do you want it back? Do you want me to get it? And sometimes it's not complete. Sometimes part of it's missing because it does like little save points while you're working. And so the last part of what you were doing might be gone, but it does a pretty good job of giving you an opportunity to pull back something that might otherwise have been lost. So modern computers don't really have a short-term memory store that looks exactly like ours. Our memory, according to what I'm going to tell you in this chapter, and then also the model, as soon as you stop paying attention to the information in short-term memory, it fades out of short-term memory and it's gone. Now, if it's something that you had retrieved from long-term memory and you stop thinking about it, it just regresses back to long-term memory. So it's not like you're going to erase something that's in your long-term memory. But if it's new information that came in through the sensory system, you paid attention to it, you're thinking about it in short-term memory, and then something distracts you. When you go back to think, what was I thinking about? It's literally gone. You can't retrieve it. It's gone. You didn't process it deeply enough. I can't remember. Maybe if the context gets right again to trigger me to start the process again, I'm going to be able to get back into it. But I can't retrieve something that I got distracted in the middle, and that distraction lasted at least 30 seconds. It's gone. It's like you never even saw it if it's new information. So older computers, like ones probably prior to 1995, were actually very similar to how our short-term memory works, but modern computers are not as well. So short-term memory would be whatever's on the screen. We call it RAM memory in computers. Long-term memory would be like the hard drive in your computer, or the SD card, or the thumb drive, or whatever you're holding that information permanently, right? So modern computers have lots of long-term memory storage options. Maybe yours can still burn CDs. I don't even have a CD drive anymore. Maybe the cloud is an example of long-term memory storage for a computer. So the model is still reasonably good. I think where it breaks down is on that short-term memory, that modern computers don't quite work the same way. And by the way, the response outcome is still going to come out of short-term memory in modern computers. You have to open the document to print it. I don't think you can print just directly from the file without having to open it. Maybe you could. If you can print directly from a file without opening it, then I guess that's another moment. I guess it's all surrounding that short-term memory that things break down on the modern computer. But I think you get the point, right? That this model is based on how computers basically function. Now I think what I need to do is come back in the next recording and talk a little bit about, like, why do we have this short-term memory store? What does it do for us? So I'll see you in the next video.